Detection of denial of service attack in VANET using Cuckoo filter. Introduction. Vehicular ad hoc networks is termed as a network on wheels where the vehicles form the component of the network. The communication system in VANET is of two types, vehicle to vehicle and vehicle to roadside unit. It plays a crucial role in building smart cities and intelligent transport systems in order to ensure road safety. VANET is an application of MANET, but it has its own distinct characteristics. Some of them are rapid change in network topology, high mobility, unbounded network size, frequent exchange of data, wireless communication. VANET in itself has a lot of security issues. VANETs are bound to satisfy some of the security requirements. They are authentication, availability, non-repudiation, privacy, and data verification. Authentication ensures that the message is generated by the legitimate user. Availability requires that the information must be available to the legitimate user. Non-repudiation. It means a node cannot deny that he or she does not transmit the message. Privacy. The privacy of a node against the unauthorized node should be guaranteed. Data verification. A regular verification of data is required to eliminate the false messaging. Some of the common attacks in VANET are cyber attack, black hole attack, denial of service attack, and jamming attack. Let's see a bit more about denial of service attack. Denial of service attack. An interruption in an authorized user access to an service which is typically caused with malicious intent. A denial of service attack involves only one particular node flooding the victim node with huge amount of packets. The main aim of the attack is to overload the victim in order to seize the availability of resources. A large number of traffic is directed towards the victim node from the malicious node, which will in turn make the node unavailable to communication. Some of the types of denial of service attack are flooding attack, ping flood, UDP flood, and Smurf attack. The existing techniques that are available to counter DOS attack in VANETs are cryptographic countermeasures, which includes elliptic curve digital signature algorithm, timed efficient stream loss tolerant authentication Tesla on Tesla++. Some of the packet detection techniques involves attacked packet detection algorithm, enhanced attacked packet detection algorithm, malicious and irrelevant packet detection algorithm. Some of the diversion techniques involves anti-colony optimization, frequency hopping technique. Some recent techniques that are used to prevent DOS attack in VANETs are swarm optimization, distributed prevention scheme using Kalman filter, packet delivery ratio value, and one of the robust technique used is IP choke detection filter, which is based on Bloom filter. The proposed scheme. The proposed scheme involves Cuckoo filter and IP choke detection algorithm as a possible defense technique against denial of service attack in VANET. Cuckoo filter. Cuckoo filter is one of the most efficient probabilistic data structures that are used in processing huge amount of data sets. The cuckoo filter consists of a cuckoo hash table which is used to store the items in the form of fingerprints. The cuckoo filter uses partial key cuckoo hashing to prevent collision among the items that are present in the cuckoo hash table. The technique involves two hash functions and the value is assigned to one of the buckets available. If there are no entries in the first bucket, the value is placed there. For the second entry after hashing, it checks the first bucket whether the value is available or not. If there is no value in the first bucket, it comes to the second bucket and places the value. Once the bucket 2 is occupied, if we enter a new value, old value is evicted and replaced by the new one. The partial key cuckoo hashing is very useful to avoid looping. The cuckoo filter stores f-bit fingerprints, so if a fingerprint has to be kicked out of its position, it has a new position in the other bucket. IP choke detection algorithm. The IP choke detection algorithm consists of three important phases: identification phase 1, identification phase 2, and the cuckoo filter phase. Initially, the first phase gathers the necessary IP addresses which is passed as an input to the next process. The traffic that comes to the network is checked predominantly in this stage. The information gathered from the first phase is sent to input to check the malicious IP address or traffic. If there is no malicious IP address, it stores the IP in the database or it sends to the judgment engine. In this stage, based on the information collected from the previous phase, the cuckoo filter alerts all the other vehicles that are present in the network through an alarm and sending some details about the vehicle. The alert is only sent to the network vehicles and not to the infrastructure. The process can be successful only based on the output of the judgment engine. Some of the metrics that are compared with the previous versions are eliminating false positive rate to less than 3% compared to Bloom filter, uses fewer bits per second when compared to Bloom filter, improvised space efficiency with optimal bucket size, support both insertion and deletion of items. Cuckoo hashing technique is used to avoid collision up to 95% occupancy in the bucket. The tools used for demonstration are NS2 as a network simulator, Sumo as a mobility simulator, and Trans as an integrated simulator. The integrated simulator is used to combine both the network simulator and the mobility simulator in order to demonstrate a perfect VANET environment. Thank you.